In this video, we'll talk about bounded sequences, which are sort of a weird topic at first, but becomes super critical when we go into talking about series in the next section. So a bounded sequence basically just means that the terms don't get too big or too small. So to talk about these mathematically, we'll be a little more particular in how we define this, but the idea you should have in your head is this: terms not getting too big or too small. So we say that a sequence has a lower bound, which I will call m, if m is less than the value of an for all n. Basically means I have a floor where none of the values of an go below that floor. In a similar way, we say a sequence has an upper bound if there's a ceiling, if there's a value where I never go above that value. And we'll call the upper bound k here just for not being m. But again, the point here is if an is less than equal k for all n, that means k is acting as a ceiling that an cannot break. So how do we use this to talk about the actual sequences? Well, we say that a sequence is bounded from below if there is a lower bound for the sequence. And I'll give some examples in a bit to discuss where this is sort of headed. So we say an is bounded from below if it has a lower bound. We say it's bounded from above if it has an upper bound. And then we say it's just plain bounded if it has both. So what you want to think of here, bounded from below means I have a floor. There's a floor somewhere that my values don't go below that number. Bounded from above means there's a ceiling somewhere that I can't break. And bounded means I have both. Bounded means I'm trapped. If a sequence is bounded, it's trapped between a floor and a ceiling, and it can't break up or break down. So some sort of brief examples of this. If I take an to be the sequence n squared for n bigger than 1, this is bounded from below. Why? Because an is bigger than or equals 0 for all n, so 0 is a floor for my sequence. 0 is a floor, minus 3 is a floor. A lot of numbers are floors. Anything less than 0 is a floor. But since there is one, it's bounded from below. This is not bounded from above. Why not? Well, I could pick any value I want, and eventually n squared passes it. N squared gets bigger than it. So whatever ceiling I want to set, I'll eventually break it. So I'm not bounded from above. Something like Bn is 1 over n for n bigger than 1. This is bounded. Why? Well, Bn is always bigger than 0, and it's always less than 2. Because I'm never going to get bigger than 2 because I start at 1 here. Since I have a ceiling and have a floor, that makes this a bounded sequence. As a side comment here, if a sequence is not bounded, as in not both sides, we say it's an unbounded sequence. That's a role you'll see coming up, both in this section and the next section. So we have some nice theorems about sequences, and now that we have the term bounded, we can sort of talk about. And the first of these tells us that if a sequence is convergent, it must be bounded. Well, sort of what's the idea here? Well, the idea is if I know that I converge, my values are all going to approach this number L. So they can't run off to infinity. They can't get too big. They can't get too small. So I have to be able to trap them. That's basically just the idea of why this one works. The second one here is sort of more impactful and more actually useful when we're trying to do things with this. That's that if I have a bounded sequence that is also monotone, I'll define that in a second, then it converges. Now what does monotone mean? Monotone means it is either always increasing or always decreasing, i.e. it's always either getting bigger or getting smaller. So increasing would mean that an plus 1 is bigger equal an. Decreasing means that an plus 1 is less equal an. And these are always statements that are meaning for all n. So like we had functions that could increase on some domains and decrease on others. That's not a useful fact for sequences. If I say it's increasing, I mean it is always increasing no matter what. And the same goes for decreasing. Then the word monotone means either increasing or decreasing. So if I say it's monotone, that means it's either the case that every single value is bigger than the one before it, or every single value is less than the one before it. And if I know a sequence is both bounded and monotone, I then know for a fact that it converges, and I can then apply limit laws to try to figure out what it converges to. That's the idea of bounded sequences. The idea being if a sequence is trapped between two numbers, it's bounded, and that gives us nice properties in terms of convergence. We'll see this theorem right here about bounded monotone sequences come up a lot in the future when we start talking about series. It turns out this will be the main way we can say that certain series converge when we get to what that means because we know it's bounded and monotone. So it's important to at least have these ideas in your head when we're going forward into those sections to deal with those more advanced concepts.